welcome to all to the most important class for moment of inertia with all concepts and also procedure. I wrote here part 1. I will tell you why. I have still not decided whether to upload this class in single class or multiple classes. The total duration required for me to completely cover, I will tell you it later what all I am covering, maybe more than 4 or 5 hours. So if there is any problem of uploading, I will upload in parts. Then you take this as part 1. So whenever I change something, I will write part 1, part 2, part 3 here. But and accordingly, I may upload in different parts. Everywhere, same heading. Of course, I will write here part 1 of, part 2 of, part 3 of, like that. If I manage to upload in single part, maybe I will take two more days it will take for me. Then I will not write part 1, part 2 in the title there. Simply upload. In between, when you see in between, when you open the class, then you can see that name part 1, part 2, ignore it. That's why I told part 1, part 2. This class I am giving complete knowledge or complete procedure including concepts how to find moment of inertia. So one by one concept I will tell you now. Actually all those who want to master this calculation of moment of inertia from beginning up to end thoroughly you have to go through, and as soon as this class is over, next immediately we are starting numericals. At that time I will use harsh words. Not clear, leave the class. I will tell that way. I got right for that one because that much effort I am putting here. People who are lazy, who cannot study thoroughly all this told, they don't deserve to study from me. Okay, therefore, again and again, same thing I don't want to tell. Okay, now, first remember one by one points. See, first, moment of inertia, I will put MI, okay, to save the time, MI. Moment of inertia, when you calculate, is always about an axis. About an axis. About an axis. That axis may be anywhere. You can write here. See, that axis may be centroidal axis, may be, see here, red color, may be centroidal axis. Who knows? Centroidal axis. Or can be any randomly given axis. Randomly given means question, in the question, given axis. That can be either centroidal axis or can be any randomly given axis. Whatever is that one, we will use parallel axis theorem. Parallel axis theorem. This theorem very systematically I will explain little later. Maybe in part 2, I will explain in part 2 or in part 1 only, I don't know. Or after giving all standard cases, I may explain. Anything will do, depending on how I feel it. Now, moment of inertia, they can ask, anybody can ask, see, I am covering academic question, competitive examination, and general public also, that is structural engineers. And remember, one make a note here, structural engineering, for structural engineering, in structural engineering, it means moment of inertia. In structural engineering, we always require moment of inertia about centroidal axis. Centroidal axis, that's all. Structural engineering point of view, we always require centroidal axis. Then somebody will ask, then why randomly given axis? See, I told you, academic question. I am covering the subject so that any day later, if someone wants complete knowledge of engineering mechanics. Either he wants knowledge or want to even get good marks. Either students writing academic examination or competitive examinations, or any competitive examination can be either objective type or regular type also. There are so many examinations where you have to answer full questions. It is beneficial for everybody. Of course, structural engineering, you understand whatever requirement is there. So, therefore, I am covering everything. Lot of examples I will cover. Now, for that, I told any centroidal axis. Centroidal axis means, see, usually you write here, centroidal axis. Consider centroidal axis. Axis, say, I'll tell capital XX and capital YY. Axis for entire given area. See, entire given area, not for component. It is for entire given area or for given lamina. That for a given lamina or entire given area, I use capital XX and capital YY. When I consider component later, I am using small xx, small YY, or I will not use red color. I will use green color for some reason. I will tell the reason for it. Why the color I have not decided still. Okay, I may use red color, I may use, but I won't give capital G. I may use small g. I will decide it later what way I want it, so that you understand. You never bother now, right now. Okay, now, first you have to make a note. See, first you have to make a note here. This I will remove later. If note, see, make a note here. If moment of inertia is required about any randomly given axis, axis or axis, then right here, there is no question of locating. See, you should write here. See, so many things I will dictate. Those who are serious should write. Then there is no question of locating that axis. Given axis, what you locate, it is known because it is given in the question. Therefore, directly start calculation of moment of inertia. If they tell the axis for you, see, somebody will take in a question, they may tell, find I about this axis, any axis, randomly they will show. Then there is no question of locating that axis. In such cases, no need of locating centroid for entire given area. Centroid means G. Centroid area by calculating, you know it, x bar and y bar. I won't explain much now. X bar, y bar, you know it. There is no point in wasting time. So if they want moment of inertia about any randomly given axis, a question given, they will ask you, find I about this axis. Okay, over, start. Then you don't require centroid G, nothing. Centroid G for entire area and no x bar, y bar. Just ignore it. So therefore, someone will ask, sir, you have not done x bar, y bar. Who asked you x bar, y bar? What they want? Sir, they want moment of inertia about that axis A, B. Then why you want x bar, y bar? X bar, y bar will come when they want moment of inertia for about centroidal axis for the entire given lamina or area. So directly start, one note. Okay, now, next note. All I am telling, one by one note. Next note. Suppose moment of inertia is required required about centroidal axis. That's the most important in structural engineering. Centroidal axis for entire area. That was important. Entire given area. For the full given area, some shape will be there. Lamina, given area or given lamina. Okay, I can use the word lamina now, much better. Lamina. Then before starting moment of inertia, before starting calculation of moment of inertia, first we have to locate centroid. No, you have to locate not centroid, centroidal axis. That is popularly called XX and YY. Axis for given lamina. Remember, XX axis is by finding, remember, Y bar and YY axis by finding X bar. X bar and Y bar from where? These two from any reference axis. Y bar is from a reference horizontal axis, and X bar is from a reference vertical axis. Any axis. Make a note. All these very thoroughly already over earlier in centroid. And at that time I told you, later when you go to moment of inertia, whenever you are finding X bar, Y bar, I will not waste my time, unnecessary wasting. So make a note. First you have to master that one, then only come here. Okay, now before you go further, one final warning. I will not tell again and again. Final warning means principle. See, this I should not tell. Okay. Final warning. See, whenever vertical axis, whenever horizontal axis considered, see, whenever horizontal axis considered, then this way considered, then distance considered is vertical. I told it repeatedly. See, whenever you consider a horizontal axis, you consider vertical distance. So axis horizontal means distance vertical, and whenever vertical axis considered, that is vertical means like, see, Y. Okay, you can tell Y. Whenever vertical axis considered, see, axis horizontal, distance vertical. Whenever vertical axis considered, then distance considered is horizontal. Yes, I am going to stop this one now. If further I will not tell. See, vertical axis means this way or this way, horizontal distance. Last time. See, I have got something here. I want vertical height, distance. It is from horizontal floor. See, from horizontal floor, floor is horizontal. From floor, horizontal floor, see, when you refer a horizontal surface, distance is vertical. Same way. I want where is this something with respect to wall here. See, if I want this distance, see, wall is vertical. From vertical wall, you find horizontal distance. So easy to understand. First of all, I should not waste time on this one. See, anywhere you take here, from a vertical axis, horizontal distance, from a horizontal axis, vertical distance. So, whenever YY comes, it is X distance. Whenever XX comes, it is Y distance. That's all. Or remember, whenever, you can make a note here, whenever YY comes, it is always X distance, and whenever XX comes, it is always Y distance. Now I will not tell again and again this one. There is a limit for everything. It is told many times earlier. If someone is still feeling confusion, you feel confused only. You don't. I will tell you don't deserve to study first of all. Okay, this is also over. Now next important note. Next note. Consider the case. Next note. Consider the case when moment of inertia about centroidal axis is required. Central axis is required. Moment of inertia for given lamina. Given lamina means given entire area. Whenever centroidal axis, right? One note you are right. Note. See, that is, it can be I about XX or I about YY or both. Make a note. You should write it. They can ask only IXX, or in structural engineering also, so many questions, so many cases you require only IXX, or sometimes you may require only IYY. In the class also, see, but if you consider academic questions, they may ask you only about XX axis, only about YY axis, sometimes both. Suppose the given lamina consists of multiple parts, 5-6 parts. Examiner, what he will do is, okay, one is sufficient, because why? Time consuming. If it is simple one, like some angle section or T section or I section all, he may ask both. Therefore, it can be either IXX, IYY. I already told you, capital XX, capital YY is for entire lamina. I told it is for entire lamina. Okay, now, then, if only IXX required, or in the words, how it will be? In the words, it will be, you write moment of inertia about the horizontal centroidal axis. If they want only IXX, then we have to locate only XX. Right here. No need of what? Locating YY. Waste of time. Locating YY. Or right here. If the question is only to find I about XX axis, there is no need of locating YY, or it is a time waste. Don't waste time. Only XX. But remember, only XX. That is, find what? In the class I will ask, offline class, X bar or Y bar? Some will tell X bar. I will tell what? I told many times for you, if the axis is horizontal, sorry sir, Y bar, yes. When you want to locate a horizontal axis, you should consider vertical distance, that is find only Y bar. Next time onwards, I will not tell. See, if you make a note here, horizontal axis can be located only by, you are based on calculated vertical distance. See, if you know the vertical distance, you can mark horizontal axis. Same way right here. And one side, right next. And if only IYY required, then we have to locate only YY. No need of locating XX. Only YY. Find only what? See, if you want to locate only YY, you require only X bar. I already told you, vertical axis means horizontal distance. Find only X bar. Do not waste time finding both. See, lastly write. If I am dictating now, XX axis required. Locate XX by using Y bar. Okay, once you locate XX, find moment of inertia about XX. You can write here. Then happily find I about XX. Or if I about YY axis required, locate YY using X bar. See, using X bar means reference vertical axis. Any horizontal distance is for vertical axis. Any vertical distance is for horizontal axis. From a vertical axis, always horizontal distance, and from a horizontal axis, always vertical distance. Told many times. And find moment of inertia. Okay, then next note. Sometimes, note, sometimes there can be symmetry. There can be symmetry. Then if symmetry is there, with respect to one axis, directly locate that axis. Directly, I don't know which one, locate that axis. Locate that axis. That is, if symmetrical about XX axis. If a given lamina is symmetrical about XX axis, then directly locate XX. Directly mark XX, not locate. Then directly not locate. Directly mark that axis, not locate. Directly mark that axis. If it is symmetrical about XX axis, directly mark XX. That is, no need of not X bar, Y bar calculation. Waste of time. I already told you X axis located by Y bar. Same way, next right. If symmetry is about YY axis, then directly mark YY. Mark YY, that is, no need of X bar calculation. Okay. Now I want to wait. I want to explain. Some will tell it's insulting to explain same thing again and again. How many times are you will explain? I have lost that rubbing cloth. Where is it? Here. Okay. That cloth is not good, but it is effective rubbing. Okay. This also. Now, next further is there. All the important concepts. How to find, I will tell you. So now, axis located. Right. Lastly, note. Sometimes, rare cases, sometimes there can be symmetry symmetry with respect to both axes, both xx and yy. Then no y bar calculation to locate xx and no x bar calculation to locate yy. Directly mark where midway, height wise midway mark xx, width wise midway mark yy. Okay, that's all. Now this is for what? Moment of inertia. Now some more concepts are there. Okay, now therefore whenever moment of inertia is required to be calculated about an axis or axis. First, if required, locate that axis. That will come only for centroidal axis. If it is a given axis, no location. First locate that axis and then happily find moment of inertia about that axis. Okay, then someone will ask, sir, how? Wait, I am telling how to find moment of inertia. I am explaining step by step, parallax theorem, all standard cases, everything I am explaining. I am in the initial part. Okay, now why I am telling? Because see, make a note here. If they want only about a given axis, find about given axis. Then there is no locating. If they want about centroidal axis for the entire lamina, if they want only horizontal centroidal axis, locate xx axis by using y bar. If symmetry is there, happy, find ixx. You should write after hearing. If they want about vertical centroidal axis, what we call yy, then if symmetry is there, locate yy directly, or not locate, mark yy, or locate yy using x bar calculation and find about yy. Okay. Now, why I am telling? Because now sometimes, I'll write here now. See, sometimes, black color will do. Sometimes instead of asking, there is examination question. See, whenever I am telling asking, if you are doing structural design, you know it is required. Suppose you are designing the column, you require radius of gyration. Nobody is asking you. Instead of asking moment of inertia about any axis, question can be to find radius of gyration. Radius of gyration about an axis, any axis, about an axis. Right here, it can be centroidal axis or any random axis. Then also, see here, then also first find moment of inertia. About that axis. About which radius of gyration is required. Gyration is required. Then also first find moment of inertia. Because, I will write here now, reason. Because we know that now by this time you know that radius of gyration, black color will do, radius of gyration about any axis any axis, that is R equal to square root of I by A. I is moment of inertia about that axis. Which axis? About which we want radius of gyration. I about that axis. A is area, total area. Total area. Area of the cross section or area of the total area of lamina. Area of the lamina. So, in case radius of gyration required, the question is similar to asking moment of inertia. Find moment of inertia. See, then I write remove this one. See, then see 1 minute. Sorry, suppose radius of gyration about xx axis required. I am rubbing now, you should write. Suppose axis required. Then that is what? That is R about xx. Okay. Then R about xx equal to square root of I about xx divided by area. Right. Therefore, first find Ixx and then find Rxx. So, asking for radius of gyration is actually nothing but asking moment of inertia. One extra line, that's all, right here. One extra line. Now you should write, see, no space right here. Same way, now, or suppose radius of gyration about yy axis required, that is ryy, then that is ryy equal to Iyy divided by area. First find Iyy and then find Ryy. First find Iyy, then find Ryy. Or suppose radius of gyration, not center of the axis, gyration is required about any randomly given axis. Say some axis, say I give AB, okay, AB. Any randomly given axis, say AB, then first find I about AB, first find moment of inertia about AB and get RAB by the formula root of IAB divided by area. So, don't tell sir instead of moment of inertia they have radius of gyration. That also same. Okay. Now, last point. I think I will upload in parts only. Otherwise, it becomes very problem for uploading. I recently have found I made a big class. YouTube rejected 2 times. They told uploading is problem. So instead of that way, and also nobody wants class to be very lengthy nowadays. So part 1 is important now. Okay, now last concept today. Suppose, now it's very important now, very important. Suppose moment of inertia is required about an axis, perpendicular to plane of the area. Then what to do? See, then I will tell 2 cases for you. Okay, see, then two cases. Two cases. Case 1. Case 1. Moment of inertia is required about an axis perpendicular to plane of area, and that axis passes through any given point, say some name required, anything, say any given point, say O, like see here. See, moment of inertia, that is, see some lamina is there here. Any given point, they can give outside also, see, some point O here, either here or here, O. They will ask you, you write here, this is a sketch given, some lamina given, they want moment of inertia about an axis perpendicular to plane of the area, see, this way, you cannot see it, see, perpendicular to plane of the area and passing through the point O, you call that is OZ. Say Z direction, Here, say OZ. It is not passing to centroid. Then, what you do? Or make a note here. This is also called moment of inertia is required about area. Make a note. This moment of inertia is also called polar moment of inertia. So then, through that point, draw a horizontal line, draw a vertical line in the plane. See, I see any name, see, OA and OB, randomly, OA, OB. Then, consider two mutually perpendicular axes, say OA and OB in the plane of the area, and find I about OA and I about OB. See, if they want about this axis, you draw one horizontal axis, OA, any name, and OB, it is not XXYY, random name. And then IOZ means, right, moment of inertia about an axis which is perpendicular to plane of the area passing through a point O by YOZ equal to I about OA plus I about OB by perpendicular axis theorem. You find this way. If they ask randomly, find that way. I will give an example for you. Or case 2. This is case 1. Case 2. Moment of inertia is required about an axis passing through centroid, that's very important, passing to centroid and perpendicular to plane of the area. Then first locate centroid. And find IXX and IYY. See, if this is a given lamina, centroid is here, G, find I about XX and I about YY. You find these, how? Already. Then, see, that Z axis. Then, that required moment of inertia or the polar moment of inertia, that is IOZ equal to IXX plus IYY. Now you have to locate centroid. Okay, or see here, make one last note. Example. One example for you. Suppose in a question, see, an I section given, see, I write here, and T section given. Make a note here, T section given. Case 1, moment of inertia required about an axis but perpendicular to plane of area and passing through a point, say P, some point they will tell, anywhere they will tell, passing through a point P, see here P. Then no locating centroid, see, this is a point P. Consider one axis here, one more axis here, call AB axis if you want, call CD axis here, passing through P, find IAB and ICD, or you can write IPB and IPC, and then that polar I equal to IAB plus ICD. Write this way. If they want this one, or case 2. I am removing because you should write it. Case 2. Same question. Case 2. Suppose polar moment of inertia is required. Polar required, where they tell what? Axis perpendicular to plane and passing through centroid. Then first locate centroid G. See, that is this way. I don't know where is centroid. Suppose imagine here, T section, it may be and G, and mark XX and YY. See here, centroid will be here, G, mark XX, mark YY. This is centroid G. Then see Z axis. Then that polar moment of inertia, that is IZZ equal to IXX plus IYY. That way find it. Okay, I have given enough information now. I have decided to upload in parts. Otherwise, class will become around 5-6 hours long. 5-6 hours long, nobody wants to study. So today, I am giving part 1. Every class I will write most important class for moment of inertia calculation. Today I will write part 1 of it. Next class will be part 2. Okay, thanks.